Hello everyone, today I'll be going through the Math Methods Unit 1-2 mini quiz for week 4. Yep, so let's start. So for the first question, we're solving sine of 2x equals negative a half for this domain specified here. So first we know that sine will be negative in the fourth quadrant and third quadrant, so that's what I've drawn here. So usually my way to do this question with a domain that's not big is start writing down solutions and eventually see which one's out of range. So we just stop include that. So I decided to write down the negative solutions first. So what I've done is so I just did 2x is equal to negative pi on 6 or negative 5 pi on 6. Or so that's the two negative solutions, because if you think about it, if we add another extra pi to it, then the next solution would be negative 13 pi on 6. And if 2x is negative 13 pi on 6, x is negative 13 pi on 12, which will be outside the domain of negative pi. So on the positive end, we would have x is either in the third quadrant or fourth quadrant. So we know that 2x is either equal to 7 pi on 6, 11 pi on 6. And I just decided to try the next solution just to see if it fits within the domain. So 19 pi on 6. And we divide everything by 2. And the solution I tested actually fit within the domain. So therefore, we have those many solutions. So, I mean, we can try to test the next one. For example, the solution after 19 pi on 6 would be 23 pi on 6. And that would go to 23 pi on 12. And actually, interestingly, that would be in the solution. So I guess that's kind of my point here. When you're doing these type of questions, always check the next solution of like the biggest one you have or the smallest one you have, just to check that it actually can. So just to be sure you include it, so it fits within the domain basically. Okay, so question 2, we have sine of 3x equals to negative cosine of 3x for x is negative 5 to pi. So that's kind of saying that tan of 3x equals to negative 1. And we can start writing solutions. And as we know, tan of 3x is positive in the second quadrant or the fourth quadrant. So we have 3x equals to 3 pi on 4 or 7 pi on 4. So that's the quadrant 2 and quadrant 4 solution for the first rotation. Then I decided to write down for the second rotation as well. And I did the exact same for the negative ones. It's just, so negative pi on 4 and negative 5 pi on 4 are the two negative solutions for the first negative rotation, and negative 9 pi on 4 and negative 13 pi on 4. Yeah, that's a 13. So I didn't really have space there, but yeah, that's 13. Yeah, that's the second rotation for all the negative solutions. So now I decided to divide everything by 3. So we have all these solutions here. So notice how this one here, 15 pi on 4 divided by 3 is 15 pi on 12, which is outside our positive domain, so we don't include that. And the final one here, negative 13 pi on 4. Negative 13 pi on 4 divided by 3 is negative 13 pi on 12, which is also outside of negative pi domain. So it's just the rest of the solutions divided by 3. And that's all the answers to this question. I guess another way you can kind of try to find which solutions in and which solutions out of range is to look at the x value in the domain. So if we have, for example, let's look at question 1. If there's 2x here, then if x is element of this domain, then we can kind of say that 2x is element of just the domain times 2. So if our 2x is within this domain, then it will be within our domain, because if 2x within this, then x is within that. So, but if it's outside, then we don't include it basically. So it's the same logic here. If x is element from this to this, then 3x is element from negative 3 pi to 3 pi basically. And notice how this one is outside 3 pi. That's why 15 pi on 4 isn't included in our solutions. I'll quickly rub that out. And notice how negative 13 pi on 4 is also outside negative 3 pi, so that's not included, so we can rub that out as well. And that's the 6 solutions we're left with, basically. So for the final question, we let u equal to log 2 of x. So, and then we can write this thing as a quadratic. So 3u squared minus 5u minus 2 equals to 0. And we factor to get 3u plus 1, 3u minus, u minus 2. So u is either negative 1 on 3 or 2. So that basically says that log 2 of x is equal to negative 1 on 3 or 2, but negative 1 on 3 is impossible because log 2 of something is always positive. Therefore, we know that log 2 of x is equal to 2. Therefore, x is equal to 4 because 2 to the power of 2 is 4. Yep, so that's this worksheet. If you guys have any questions, feel free to ask me. And yeah, I'll see you guys all next week.